Hey, welcome back to Fat Mama Physics. In these videos, I'm going to talk about uncertainty propagation. So that is essentially what happens when you start to manipulate your data values that have uncertainties attached to them, so that after you manipulate your data, how do you deal with the uncertainties? So the 4 videos that I will have, the first one is going to be on adding and subtracting, as you can see here. The second video is going to be multiplying and dividing numbers with uncertainties. And the third one is going to be multiplying, or I mean, it's the same thing as dividing, but essentially multiplying by a constant, so a number that does not have an uncertainty. The fourth video is going to be what happens if you put an exponent on a number that has an uncertainty. Okay, so those are going to be the 4 videos. Before we dive in, I just want to make sure that you fully understand what absolute uncertainty means and what relative uncertainty means. If you don't know what those two mean, or how to get them, or how to convert from one form to another, then this video is going to be very confusing for you. Okay. The other term that I'm going to use, which then I might put in here and there, is something called fractional uncertainty. Fractional uncertainty is one form of your relative uncertainty, but specifically it is in the fractional form. So let's say you have an uncertainty of delta A, for example, okay? If I put that over my original data value A, then this raw number here is my fractional uncertainty. It is one type of a relative uncertainty. Because relative uncertainty, you can express it as a decimal, you can express it as a percentage, which is often the case, but then sometimes we don't need to really put it in percentage because it's not useful for us. It's much better when we have it in a fractional uncertainty form when we do some of these calculations. So I might use this word fractional uncertainty, which what that is a type of relative uncertainty in the fractional form. Okay, just to make that clear. Now, I'm going to start off in this video with adding and subtracting numbers with uncertainties. I want to turn our attention to this box in here. I have 3 data values. I have A, B, and C. Throughout these videos, I will be using these 3 numbers with their units and whatnot. I'm going to use these 3 numbers. And that's attached, and to that I have a number and I have an uncertainty. So if you don't know what A and B means when we're doing a question, go back to these 3 numbers, okay? So then the other thing I'm going to be doing in this video is I will be alluding to your IB data booklet that will have all of these equations for you. So if you want to have that out, I'm going to be actually showing you that. So if you're just wondering, it's this part of your data booklet, I believe is page 5, the uncertainties and errors. Okay, so let's just do that. Okay. So when you add and subtract numbers with uncertainties, what you need to do with the uncertainties is you need to add their absolute uncertainties. Okay, so in your data booklet, so there you go, I'm gonna go to data booklet, bam. Okay, so here we have some examples here, and it says here if y is equal to a plus or minus b. What this plus or minus means is either if you're adding or you're subtracting 2 numbers. Okay, a and b are just 2 random numbers. So if you're adding or subtracting, that's what this statement says, then your delta y, and notice here this delta sign means uncertainty. The uncertainty in y, or specifically the absolute uncertainty in y, is equal to the absolute uncertainty of A plus the absolute uncertainty of B. And notice that regardless, even if you're subtracting the 2 numbers, you are still adding their absolute uncertainties. Okay, you might be wondering, oh wait, but I'm subtracting. Why am I still adding their absolute uncertainties? The idea here is that whenever you put numbers together or you manipulate numbers together, Before you were just this much uncertain. When you start putting things together, you're gonna be even more uncertain of your end result. It's like you have one crazy kid in a room, like my baby, for example. And man, there's all these potential possibilities that something's going to go wrong in a room. Let's say you put two crazy kids in the same room. Then there are endless possibilities of what they can do, how to mess up your living room or whatever. Okay, so that's the idea. When you're adding uncertainties, you become less and less certain, especially when you're manipulating numbers. Okay? That's the analogy. Oh, I don't know if that works. Okay, here. In your data booklet, the general form for this operation is, I can write it down quickly. Okay, so plus or minus, you always add absolute uncertainties. Okay, notice this plus minus sign in your data booklet means either you're adding or subtracting. So let's do some examples. Whoa, I put, interesting. I swapped the order here. Actually, I'm going to do example 2 first. Okay, I'm going to do example 2 first, and I'm going to give you a chance to go back and do example 1. Haha, okay. So let's do A plus B. The first thing is you just add up the numbers, okay? That's if you don't know what to do with your uncertainties, let's say you're stuck. This is a no-brainer, A plus B. And I'm going to go back to this chart here that I created 3 numbers for you to use. So I'm just going to do this math quickly. That's my result, 8.78 meters. And because I don't have the uncertainties right now, I am not going to do any sort of rounding at this point, okay? And I'm going to say that after A plus B, that's equal to Y, so that my absolute uncertainty for the result, which I'll call it Y, this is equal to the sum of their absolute uncertainties, which then, if you go to this table that I have up here, it is the 0.03 meters plus the 0.2 meters. That's going to give me 0.23 meters. And now with the calculator, I just want to check whether or not 0.23 is less or greater than 2% relative uncertainty compared to my original value. Otherwise, I have to round this to 2 significant figures. So let's do a quick check. Okay, so it looks like it's definitely larger than 2% relative uncertainty. So I'm going to need to round this up to 1 significant figure. Okay, it's larger than 2% relative uncertainty. Round this up to 1 significant figure. So 3 is going to round the 2, or is going to keep the 2 at what it is. So my final answer is going to have a 0.2 meters of absolute uncertainty. And this is going to determine how I will round my final number for Y, which is the sum of A and B. So that's going to tell me how to round 8.78 meters. Since I have the uncertainty in the tenths place, I'm going to need to round this up at the 7. I'm going to round the 7 up or down, depending what I have afterwards. This 8 here is going to round my 7 up to an 8. So I'm going to get 8.8 meters for my data value, okay? And this is my final answer. Okay, so now it's a good time for you to try example 1, which is A minus B, okay? Good time to pause the video. Okay, now I'm going to do it. I won't do it on fast play, but here. So I'll have that equal to Y. A minus B is 7.48 meters from my data table minus 1.3 meters. And that's going to give me 6.18 meters is going to be my, it's going to be what it is. And then for my absolute uncertainty, don't forget, even if you're subtracting numbers, you still need to add their absolute uncertainties. And since that's going to be the same as the previous answer, I'm just going to copy that over, 0.23 meters. Okay, and the rounding is going to be similar, but let's double check. Actually, you know what? We don't really need to double check because we know that 0.023 is going to take a larger percent of a smaller number, 6.18, definitely going to be larger than 2%. If you really want to, we can just double check. Okay, and we can see that it is definitely greater than 2%. Okay, so rounding up to one significant figure, the 3 fails to round the 2 up. I get 0.2 meters as my uncertainty. And again, I'm going to need to round my 6.18 to the 10th place. The 8 is going to round the 1 up to 6.2 meters. And that is my final value for the subtraction there. Okay, I'm going to end with an inquiry question. In which of these two examples, example 1 or example 2, is the relative uncertainty larger? And why? So good time to pause the video now and think about it, and we'll talk about it afterwards. Okay, so if you said that example 1 is going to have a larger relative uncertainty, you are correct. Okay, why is that so? Is because there is this example 1 and 2 uses the same absolute uncertainty. And if we're taking that over a smaller number on the bottom, this 0.2 meters is going to take a larger fraction of your original data value, therefore having the larger relative uncertainty. If you don't believe me, I actually just did that, but let's show you what that looks like. So in decimal form, 0.2 over 6.2, that is roughly, okay, fine, I'll do this one again. That's going to give us 0.032. That's roughly about 3% relative uncertainty in the percent form. And then for the example 2, I get 0.022, which then is going to be roughly 2%. Okay, so definitely number 1 takes the cake. And this is interesting because you'll notice that when you start subtracting numbers, when you're analyzing data and having to manipulate the uncertainties, something to be mindful is that your relative uncertainty is going to be larger. And it doesn't mean you don't subtract your numbers. You still have to do it anyways, because that's how you would calculate your results, however you want to do that. But just something to keep in mind, something interesting to keep in mind. All right, so great job, guys. That's it for this video, adding and subtracting. The next video, we're going to look at multiplying and dividing these numbers instead. Good job. I hope this video helped, and Fat Mama Physics signing out for now.